Hello and welcome to our virtual lunch and learn. Today we're talking about software-defined networking. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Jeff Smith with Dynics. Ready to answer your questions out in the comments today is Kaz Viscontis, Systems Engineer out of our Flint, Michigan location. Feel free to enter your questions in the comment section as we go along, and we'll have a Q&A portion at the end for Jeff to answer those in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us here. As you come in, let us know where you're tuning in from in the comment section. This is our last live stream of 2021, but you can always view recordings of previous virtual lunch and learns on our YouTube channel under the virtual lunch and learn playlist. And we'll be back again in the new year with fresh Mac and Mac Live content for you. For anyone just joining, welcome to our virtual lunch and learn today. Software-defined networking. Let us know where you're joining us from in the comments. Feel free to type any questions as you have them in the comment section as our presenter, Jeff Smith, talks about the next generation of plant floor networks. Our specialist, Kaz Viscontis, is available to chat with you. He's out there in the comments now. Hi, Kaz. And we'll have a Q&A segment at the end for Jeff to answer your questions. If you'd like to reach out afterward, or if you have further questions for Jeff, you can send us an email at macandmaclive@mc-mcu.com. Just be sure to let us know the session that you attended. We'll have that email address on the screen at the end for you. Looks like we have a number of folks here with us today, so let's go ahead and get started. Jeff, I will pass it over to you.
Thanks, Rachel. Appreciate you having me on today. So first thing I want to start out by saying is this is a serious technology, but my presentation will be kind of in a casual way. I've been doing this for a while, and I can talk all the tech that folks like to talk. But with something like this, I try to reach a happy medium between being overly technical and not technical enough. And having said that, as Rachel mentioned, I'm available for further questions or a deeper dive if that's necessary or you're interested in more information. All right, let's kind of get going. Let's start out with what is a software-defined network? That's a big question, and it's usually answered with a really complicated network which decouples network control packet forwarding functions, enabling the network control to become directly programmable and abstracted from the applications and network services. That's a lot of words. What that really means is it's a centrally managed network. It's flexible, it's programmable, it's based on open standards, and it's vendor neutral for the OT space. It also means that OT staff or IT staff can easily manage the network, make changes as needed while remaining secure, which is kind of critical. It's also very difficult with traditional networks. All of this without having a degree in network. First thing I'd like to talk about is, and this is by no means the whole list. This is a subset of the list. What are some of the common OT network problems? My background is I spent 30 years in manufacturing as a customer, launched my first Ethernet-based controls networks in 2006. So we were a bit on the bleeding edge. So I've experienced most of these myself, which, for better or worse, has been a great learning experience, and we've tried to apply a lot of that to what we're doing today. OEM engineers waiting for one of my guys to configure switches, then complaining about it or using that as an excuse for lost time if they were having issues with their builds. No switch backups for any switches in the network. So if a switch goes down, what do you do? I've had people plug cables into the wrong Ethernet ports on switches. So if you're using technology like virtual LANs, VLANs, and it's supposed to be plugged into port 2 and they plug it into port 6, everything looks fine, but it's probably not going to work. Over the years, I've run into firmware issues or mismatches between firmware on switches, loops in the network. Loops are hugely painful. You can create a loop on one side of an assembly system, a body and white system, or what have you, powertrain. It's going to take the whole network down, or there's a good chance it's going to take the whole network down. No visibility, right? That's a big push. Everybody wants visibility into the network. They want to know what and where they're connected to. What kind of devices are out there, what's going on. No visibility regarding what protocols are in use on the network. And there's software today It gives you monitoring capabilities, but none of it's actually a part of the network. None of it is actually wrapped in the network fabric. So it has to go out periodically and look at things. It has to sniff packets of data as it comes by. So none of it could be called nearly real time. Being a controls guy, I think real time in microseconds. So I use the term nearly real time a lot. So those are great tools for some level of visibility, but certainly not real time visibility. No visibility into events. If somebody plugs something into the network, other tools may tell you that in 5 minutes, 10 minutes, 2 hours, 3 hours. With an SDN solution, you know immediately. You know within milliseconds if something's been plugged in, where it's been plugged in, what it's trying to communicate to, and with what protocol it's trying to communicate. You don't have the ability to prevent unwanted device communications. If I walk up to a switch and plug into an open port, and there's something on that switch that I want to connect to, chances are I can't. You don't have the ability to prevent unwanted protocols. I remember years ago, predominantly our networks were Ethernet IP. Someone happened to have a poorly behaving Profinet driver on their laptop. They plugged into our network and it took the whole network down. So we simply couldn't prevent that protocol from getting on the network. I can't tell you how quickly drawings get out of date. Once the equipment lands at the customer site and it's been there for a while, the topology drawings and what it looks like, what your network looks like, just gets out of date. Traditional OT networks either have no redundancy or reliability, or if they do, there's a lot of connectivity, or complexity. I can't tell you how many sites I've gone into and they've, oh yeah, we have dual uplinks, or we're dual home back to the IDF. Well, I find that ends up one of the cables is completely physically disconnected because the configuration and the complexity of the system was too much, so it wouldn't allow it. It's a painful learning curve. If you're not necessarily a network person or an IT person or spend a lot of time learning, learning how to manage Ethernet is not the same as learning how to manage ControlNet or DeviceNet or Profibus or some of the other types of networks that we've had in the past. It's got quite a learning curve. Replacing switches, or edge devices, PLCs, and it's very difficult to monitor the spread or introduction of malware on a controls network, because that stuff can get in pretty much anywhere. And unless you have endpoint on PCs, what prevents it from getting to other devices? Let's suppose for a minute that there was some sort of attack that someone could use to compromise the firmware in a PLC or the firmware in some other device by introducing some type of malware. There's really nothing that you can do on a traditional network unless you happen to be able to get that malware to pass through a known point, maybe perimeter. But right down to the switch level, it's very difficult. Fun fact, SDN networking is IEEE 802.3 Ethernet compliant. What's that mean for normal folks? It's the same Ethernet you're using on your network today. Runs the same application, same data, same everything. The only difference between SDN and the networks you're using today is how we manage the network. It's not the network itself. If you've got an application you like and you're using, like, for example, Rockwell's Asset Center, keep using it. It'll work just fine. It's standard IEEE 802.3 Ethernet. There is nothing proprietary or custom about it. All right, SDN uses a concept of flows. So a flow is a connection between two devices on the network. So when you configure SDN network, in particular our SDN network is NetOptics, you do it by devices. So for example, you might say that I would like this PLC to talk to this HMI over Ethernet IP. So you create a flow or configuration in the controller that allows this PLC to communicate to that HMI, but only over Ethernet IP. For example, I couldn't ping this, right? Or if I logged into this HMI and I went to a command prompt, if it was running Windows, I couldn't ping this PLC. It's only Ethernet IP. I couldn't get to the web browser on this PLC. It's only Ethernet IP. The entirety of the network is denied by default. So that means that all of these red lines, nothing can talk to anything over any protocol until it's allowed. And you get to do that from a central point of management. So instead of having to run out to all these switches and configure things like you would a traditional managed switch on the plant floor, you can do it all very easily from a central point of management. Other things the network allows in this whole concept of flows is, what happens if it picks this as the fastest path? Because in the world of SDN, our network will pick the fastest path between two devices. What happens if that breaks? If that connection is broken, if that connection is broken, it'll calculate the next fastest path and reroute all the flows dynamically so that the communications doesn't get degraded. You don't lose communications. These two will continue to communicate. If I were to break this one, it would route it this way. There's an algorithm called Dijkstra, which has been used for a lot of years, and it's designed to pick the fastest path between any 2 points. And we use that algorithm in our controller to make sure that we're always using the most optimal communications. Allowed traffic. So how does this work exactly? So when this PLC attempts to communicate with this nut runner, if this has been done before, the switch doesn't have to go back to the controller to ask it any questions. So in this instance, it says, okay, I've seen Ethernet IP between these two before. I have a flow that allows Ethernet IP between these two. I'm just going to go ahead and allow it. The controller is not involved because this is previously seen and allowed traffic. So what that means is this controller could go away and my network will still continue to function. What if it's unknown or new? Well, what happens there is if this PLC, this Schneider PLC, attempts to communicate being something like Modbus TCP, for example, the switch says, I don't know what Modbus TCP is, so it sends a packet off to the controller. The controller looks at its set of rules and says, oh, I have a rule that says anything that wants to talk Modbus TCP can. Or the controller says, I have a rule that specifically says that PLC can talk to that nut runner over Modbus TCP. So after the switch is informed of this, the flow is created across there based on direction from the controller. It'll never go back and ask the controller again if these two devices can talk, because there's already a flow in place for that. Now, in this example, there's one switch. There could be 10 switches. There could be 50 switches in the chain. But, obviously, for sake of example and demo here, I'm just kind of going with one switch idea. Now, what if you explicitly deny traffic? So if I have specifically said, I don't want to ever see Profinet on my network, then I can explicitly deny Profinet. The switch will see the Profinet come in. It already has a flow, it's called a block flow, that says don't allow Profinet on the network. So the packets are dropped on ingress to the switch. I may have chosen to be notified anytime I see Profinet on the network, and in which case the switch will notify the controller and it will get entered in the audit log and perhaps alerted, users alerted. I often get the question here, and it's a great question, is why if the network is denied by default, do I have to block the Profinet? Because it's not going to get through unless it's already allowed. Well, the reason for that is, as I mentioned a moment ago, when this switch sees something that it already doesn't have a flow to allow or block, it sends a packet off to the controller. The controller says, I have no rule for that, so don't allow it. The switch blocks the traffic. The next time this PLC attempts to communicate, which is pretty quickly, the switch says, I have no flow for that, sends the packet off to the controller. By creating an explicit block flow, the Profinet packet gets to the switch. The switch says, I have a block flow. It doesn't need to consult the controller. It simply discards the traffic. Fun fact, VLANs, spanning trees like RSTP, loops, and complex networks are a thing of the past. You do not need to use VLANs on an SDN network. You do not need to use things like spanning tree or, any of these loop protocols or redundancy protocols. The network already takes care of that. So what's that really mean? You don't need to create 12 VLANs to segment the traffic for security. SDN micro segments the network with point-to-point or device-to-device flows. So the flows are that micro segmentation. It is significantly more granular and secure than using half a dozen VLANs. You can't create a loop in an SDN network. You can plug cables in however it makes sense to cable your system, and you won't be able to create a loop. And again, no need for topology protocols such as RSTP, PVST, or various ring protocols. Cable the system how it makes sense. I will tell you that when you start working with SDN, it's kind of it's taken me, I've been doing networking for a long time. It's taken me quite a while to wrap my head around all the stuff I don't have to do anymore, and I can still reach or exceed any level of security I've been used to before. I still to this day occasionally find myself thinking, well, I would do that with a VLAN, and then I have to stop and say, I don't need to do that. And that's common with customers who start working with us on the SDN solution. SDN's been around a long time. It's been around about 10 to 12 years. It's very, very predominant in the cloud space. It's almost exclusively in the cloud space. They don't use much other than software-defined networking. It's rolling into data centers. More and more companies are adopting this. We are the only ones that have done it so far for the OT space, although a lot of people are talking about it because it makes a lot of sense in the OT space. If you look at traditional SDN, there's maybe half a dozen gaps that on the surface, when you look at it, you think it's going to be a real problem. And some companies, they've even tried it on the plant floor. But unless they bridge those gaps, it makes it very difficult to use SDN. If you bridge those gaps like we have, using many, many years of plant and manufacturing experience, all of a sudden it becomes, why wouldn't I use this on the plant floor? Why would I consider using anything else? That's some of the information that we can get into more at a later date. I have a limited amount of time, but there's just a tremendous amount of information available regarding our SDN solution, NetOptics. Another fun fact, NetOptics allows you to connect your spanky new SDN network to your existing older technology network. This is one of those gaps I talked about. Everybody, most folks have, I would say, tens of thousands, hundreds of switches out there using traditional or legacy networking technology. To introduce SDN and not be able to communicate or intercommunicate with those networks would mean a lot of ripping and replacing, which is probably not likely in a lot of ways. In some ways it might be. But what that really means is that our controller can connect to networks that use spanning tree, VLANs. NetOptics will automatically detect any VLANs, trunked VLANs, spanning tree, PVST, wherever it touches those legacy networks, and it understands them and it knows how to talk to them. So we don't need that on the SDN side, but we can talk that lingo. So you can literally have a traditional network on one side, you can have SDN in the middle, traditional network on the other side, and talk directly through the SDN network to both traditional networks. So we've made it very capable of expanding existing networks or intercommunication with existing networks, because it's kind of necessary, at least in today's environment. If we talk a little bit about the dashboard, the NetOptics dashboard, and we'll get into the software a little bit in a moment. If you look at this, when you log in first, there's a dashboard, and there's lots of different options and widgets that you can put on the dashboard. The three of my favorite things are connections with the highest bandwidth. So I can see that this engineering laptop is talking to this PLC. It's using ping, and its bandwidth utilization so far has been 53.3 megabytes. And I can kind of look that these two are talking, these guys are talking. So these are my highest bandwidth items. The rules in the system that are generating the highest bandwidth and the most packets, the largest packet counts, are these rules. So I can actually get a look and see how much traffic any connection or rule is allowing. And it's kind of nice because then I can dig into it a little bit and understand, what's going on. I can even look at traffic over time and say, hey, what's going on there, right? We have a very well fleshed out northbound API that allows external applications secure access to information on the network. So your existing IT groups and organizations that have SIEMs that they like to use, or things of that nature, can use that data from the controller. And one of those things they might want to do is look at analytics, right? Look at analytics over time and say, okay, for the last 6 months, this device has been talking to this device over Ethernet IP, and average bandwidth or byte count per day is 10,000. Well, for the last 4 days, it's been 120,000. Why is that? Does somebody need to look into that? So that kind of capability is very powerful. You can also look at switch utilization across the network. Now, as you can see that our switches on our network here, because it's a development/demo network, are pretty low. There's not a lot of utilization, so I don't have any schmecky charts to show you there. Topology View. This is probably one of the greatest features in the tool. You can have a visual topology view of the entire network. You can have multiple networks in here. It doesn't have to just be this one. I can zoom out and have 15 different networks of 20 devices and switches each and manage them from this controller. The controller operates at layer 2, which is to say it doesn't need an IP address of anything on the network. It's more interested in what devices are talking at a lower level. So you can have multiple networks, all with different broadcast domains or IP addresses, and the controller can still manage them. We have the capability to manage the network with something called in-band or out-of-band. Out-of-band means the management of the network takes place in a separate complete network altogether. So there's a port in the front of the switch. It's the management port. You plug a network into that. Then all of the data actually flows on a physically separate network. That's used in very high secure environments. Most folks in the manufacturing automotive space probably don't need to do that. So one of the features that we've built into our controller that is not common, in fact, I'm not aware of other SDN controllers that can do it, is the concept of in-band management, which means all of the network management traffic is encapsulated between switches. So we don't need a separate network to manage the switches. We have secure pipes between them and the controller. Things you can look at as well is you get an asset inventory of devices. So here's the devices on the network, right? I've got 1738, 1756. I've got their IP addresses, their MAC addresses, what type of device they are, what level do they fit into in my controller architecture? Are they a part of a specific zone? I can go in and set specific VLAN information on them if I actually want them to participate in a VLAN with a legacy network. So it's just, again, flexibility that we've built in that allows you to move legacy networks to SDN without a lot of difficulty. And there's a number of other options available, but this gives you a real-time list of what's on your network, an asset inventory. So all the other tools that are out there today that give you asset inventories, that's only as accurate as the last time it went out and actively looked for that device or captured passive traffic. And if you know you're capturing passive traffic, you end up having to tap the network all over the place. So you have these little collection points all over your network. With SDN, that's not necessary. We know what's on the network. We know what port it's on. We know what it's talking to, and we know with what protocol it's talking, always. Fun fact, NetOptics allows you to enter learning mode, where traffic on the network is learned and the rules are automatically generated. The greatest use of this feature in my mind, of having built and bought a lot of equipment over the years, is out at a supplier site. If they get all of the switches in and power them all up, put the controller in learning mode, and whatever it wants, whatever somebody wants to talk with between whatever, wherever, if they plug their laptop into op10, 3 days later, they're down working in op60. They're using RS Links and Logix 5000 or Studio 5000. It just allows that to work. It automatically generates any flows needed to allow that traffic to work. And when I get ready to move the equipment to my facility, I can whack that rule set or go in and prune out the rules I don't want. Maybe I don't want FTP on the network, but somebody used it while it was in learning mode. So it gives me a lot of power to see what's on my network at any given time in real time and use that to build rules without having to manually do that for all potential rules on a network. I kind of gave you my what does that mean already, right? You put the network in learn mode and you let it do what it wants to do. One additional fact is you can put a single switch in learn mode. So if you're 6 months into an equipment being delivered at the end user and you have 3 more machines, maybe it's phase 2, You don't want to put the whole network in learn mode when you tie those 3 stations in, because maybe something's been blocked, 12 stations away, that if you put the whole network in learn mode, it would learn that and say, oh, that's okay. What you can do is put just the new switches in learn mode so that only traffic that's in and out of those switches explicitly will get learned. Makes it very easy to continue to use learn mode, but not have to manually enter a lot of level configuration. So organize the network using a level approach. And yes, the pun was intended. A lot of folks like to design their networks using something called the Purdue model, or something similar to the Purdue model. And in doing so, they build these levels of the network. So we've got the industrial level, control level, visualization, DMZ, and business administration. If I have 150 VFDs out there, I can see that this is the blue level. It's clicked up here as well. So anything in the blue level is allowed to communicate with anything in the yellow level, because these two are clicked together. It cannot communicate above that. If I decided for some reason that HMI needs to be down here, I can grab this box, drag it, and drop it. And if I have 500 HMIs across this system, I have just modified the network virtually, it's software defined, and I have now allowed all 500 of those HMIs to potentially talk to everything in these levels. You still need to have a rule that allows it, but this is kind of like the guiding principle for your network. You can override this as well if you're an administrator, but the very nice thing you have here is the ability to organize and set levels and capabilities and functionalities visually, and know that your network is just doing what you do. So if you make changes to it, it applies all those changes in real time. Very powerful. Logging and alerts. So with logging and alerts, it gives you a look at what's going on the network. So you can get network categories, applications. You can see other lower level categories like new protocols were found. So I saw SIP for the first time. I saw ICMP. Somebody renamed a laptop on the network, so I saw it change. If they changed IP addresses, I would see that. I would see where people are, I moved a device to a port 5 on a new switch. It's extremely powerful, gives me a tremendous amount of detail. We have a alerting and reporting application that also gives you the ability to subscribe to various types of reports or various types of alerts, and it will notify you when those types of events occur. So it's very, very handy. Fun fact, NetOptics provides a power-up recovery mode to make sure the controller and the operations are synced. What does that mean exactly? In the world of controls and manufacturing, if you have an ACD file for your Studio 5000 project and it's 6 months old, you walk out and you connect to a PLC that's running production, and you need to make a change. When you connect to that PLC, Studio 5000 says, well, your project is different than the project in the controller. Should I upload, download? What do I do? Well, if you don't know that what you have as an ACD file is in fact the absolute latest master, or if they're in the middle of production, you simply can't override what's in the controller, because that's going to take the controller offline. 99 times out of 10, you're going to upload into your laptop. Excuse me. We've built that same functionality into this network, because if it's running production, once the controller is up and you've configured the network, you can take the controller offline in most cases. So if you take the controller offline and then later you plug it back in, or let's say you turn it on, you make changes, you make a backup on Sunday. On Wednesday, you're into the controller, you make a few changes, save it, and then you go about your business. On Friday, the virtual machine that you had running the controller fails. So you recover by spinning up a new version of the controller, you apply the backup to it, but now the network had changes on Wednesday that didn't exist in your Sunday backup. NetOptics will go out and interrogate all of the switches on the network and rebuild the configuration as a change set based on what it sees on the network, and give you the ability to apply those changes to the controller, which then resyncs the controller to the network. Again, what's on the floor running production is treated like the master. Now, you can go the other way, and you could tell NetOptics to, yeah, blow away everything's out there. I want it to just look like this backup, and it can do that as well. You can also run in redundant mode. So you can have, two controllers running redundantly. It gives you the ability to have one goes down, you have a secondary. Now, in the interest of time, I have a demo that I recorded yesterday, but it kind of shows the features and functionality, and I'm going to talk through it. If it happens to hiccup or you're not able to see it for some reason, I'm sure Rachel will let me know, and I do have the software all running, which I could jump over to and demo live. So when I launch the controller, in this case, I've got RS links running, and I've got 4 devices on my network. I'm also trying to ping one of those devices. Ping uses the protocol ICMP. So the device happens to be .204. Now I can grab and click on the 2 devices that I want to work with or demonstrate. In this instance, the controller shows me the path between those 2 devices. I can also see what allowed protocols are being discussed or allowed. I can see a none on SIP and a none on ICMP. That tells me that they're not allowed. There's no rule in place for it, but the traffic was seen. So now that I've said allow, if I jump over to RS links again, you're going to see that I can now talk to that because that network is allowing SIP communication across multiple switches. I'm not allowed to ping it though, or the ping is still failing because I have not allowed ICMP. Now, one side note is every time I click back from the other screen, I lose what I had selected. Normally, when you're on the controller, that doesn't happen. So if I allow ICMP, which is ping, and I go back over to my command prompt, you're going to see that I'm now able to ping that PLC, as well as still see it via SIP and RS links. You can also get a list of what that connection is allowing traffic-wise. I can allow, monitor, block, or alert. There's definitions for each of those. In this instance, if I were to say, let's block ICMP, so now I've written an explicit block rule to the network, you're going to find that I can no longer ping it, yet I'm still able to talk with Ethernet IP. No issue, no concerns. Clicking on devices gives you information relative to those devices. I can see that I have a PLC plugged into port 3, a laptop plugged into port 2, and a PLC into port 5. I can see the types of devices. I can see my neighboring switch and port 1. I can't tell you how many times I've been trying to help a remote site troubleshoot, and they tell me the network looks like this, and it's not actually cabled like that, and these aren't actually in those switch ports. In this instance, I don't have to ask them what it looks like. I know exactly where things are plugged in. They could be sitting in Mexico in a plant, and I could be sitting in Detroit. Lots of other options for managing views. I can look at, name, address, MAC address, IP. I usually prefer just to look at the name and the IP address. I'm not one of those who needs to see the MAC address. I prefer to think of it in terms of IP address. Okay. The next option is zone management. So you can organize all of the devices in your network into zones. And then by doing that, you can do traffic control by device, by zone, and by type. So I could, for example, say all of my HMIs are going to talk to all of my whatevers. Now, in this instance, I have a laptop on the network. So I'm going to say all my laptops can talk to all of this particular PLC, right? The L43, which is SIP, and I can select allow, save it, review the change, and it shows me what the change is. I could have 10 changes in here, and I can apply them. And what that does is it allows me to communicate between the laptop and whatever device I chose. In this case, it was .26. The fact that I can click into it lets you know that I am able to speak to it. RS Links simply hasn't caught up yet. We'll give it a minute. There we go. We refreshed it a couple of times, and now it shows the connectivity to that second device. So I can build more complex rules here or broader scoped rules here than trying to do it on the topology page. I might say, for example, let all my HMIs talk to all my PLCs. And if I have 50 HMIs and 50 PLCs, I can do one rule that lets the controller know all of this communication is allowed over Ethernet IP. Okay. Switch management gives me the ability to look at the switches in the system. These happen to be two of our lights. The devices, we talked about that with the picture a few minutes ago, right? Name, address, MAC, what type it is, what level it lives in. Policies or rules. In this case, these rules are the rules that I created in the last few minutes. So when I did that click and click on that topology page, that's what created those first two rules. And then I did the click and click, and I did a block rule. Right? I'm going to get rid of the block rule to allow, that should allow ping to begin again. Right? Once I've gotten rid of the block rule, it'll immediately remove the block rule, write the flow for the allow rule, and away we go. And then when I did it from the traffic control page, I said allow SIP on type laptop to device L43. And I can get rid of that as well. When we do that, you'll find that I can click on that all day long. And even though RS Links hasn't quite caught up to what's real on the network right now, it will not let me edit or go into that device. And I probably spent more time than necessary fiddling with it, waiting for it to catch up. But as you can see, it's now X'd out because I've told it can't talk to that device. All right. This is one of the tricks you can use, by the way, in RS Links to get it to refresh what its allowed communications are, or what it actually sees and what it doesn't see. In this instance, it hung up a bit. So I had to fiddle with it to get it to come back. There we go. So that's the one device we can see on the network right now, is the 204. And that's because we still have that allow SIP rule in the controller right there. Okay. Now, the nice thing about it is once you get familiar with how this works, you can actually edit rules right here. So I could say allow SIP on device engineering laptop Win 10 Pro to any. And when you're making these videos at like late at night, you sometimes forget spaces like that. So I can create this rule. I get the little green line, and I can hit save. What this means is my laptop, engineering laptop, can talk to any device it wants to with SIP. So if something tries to talk to that laptop, or that laptop wants to talk to something with SIP, it can. So now you'll see that all of the devices in RS Links are seen because all of them are allowed to talk to that laptop. So it makes it really nice. You can do one-to-one, one-to-many, many-to-many with simple rule changes. And if you don't like editing them like this, go back to the traffic control page. It allows you to do the same thing, okay? And as you'll see, these things will fall off because we just removed that rule. And if I remove that rule as well, we'll see that ping stops. So another good example of creating rules with this traffic control is I can say everything that's a laptop can talk to everything of type PLC, SIP and allow. Save it, review it, apply it. Now I should see 3 of 4 devices. So protocol SIP on type laptop to type PLC. So the 3 devices that are PLCs can now talk to my laptop. The 1734 AENT module cannot. It is not a PLC. It's an I/O device or remote I/O device. You can get really broad and say on any. That's going to allow anything on the network to talk Ethernet IP to anything else. So that there's a tremendous amount of flexibility in how you do this. There's a lot of configuration options in the controller. I'm going to skip through most of them. Down here is where you can enable controller redundancy, so you have a primary and a secondary. This is where you can configure level setup. So if you want to do this overriding level control of your network and level set your network, so to speak, you know, I can decide that remote I/O belongs up into the control network or the control level. I can decide that other devices like virtual machines belong in visualization. A scale belongs in the control level. Sensors belong in the control level. And then I can decide, you know what, that sensor really doesn't belong in the control level. It belongs in the industrial level. So you're making virtual changes to a massive, potentially massively large network, and you don't have to run out to every single switch or play with cables or do anything else. You are just telling those switches to behave and allow different things based on how you're virtually configuring the network here. It's extremely, extremely powerful capabilities. There's other options like change sets, logs, and we talked about change sets, application management. There's a number of different things that are available, but that was really what I had time for today. That was really some of the more important or the interesting things to show you. So I wanted to run through that. That's kind of the end of the demo portion of this. And I think from a time perspective, let me stop the video here and move on. So I think we've reached the end of my part of this presentation. I think I'm hopefully within my time. About 40 minutes is what I thought this would take. So I will hand it back to Rachel.
Thank you so much, Jeff. And yes, well within your time. And thank you so much for all of this wonderful information and that great demo. We don't have any live questions in the chat right now, but we do have a few questions that our customers might have for you that I'd like to go over if you don't mind.
Sure.
So the first one is, does the controller have to be on and connected to the network all the time?
So that's a great question. The controller, technically, if you're just running an SDN network, does not need to be on or connected. Generally, you will want the controller on simply because then you can get the alerting, the logs, the visibility. You can see when things happen. If the controller is not online, the network still runs. You could cycle power to a switch and it'll come back and your whole network will recover exactly how it was the last time you made a configuration change via the controller. But yeah, you can take the controller offline in most situations and the network will run completely by its, completely as it should. Again, there are some, depending on how you're connecting to some traditional networks, there may be a couple of caveats there, but by and large, yes, the controller can go away.
Great. And another question that Kaz has just entered in the chat as well that our customers might have is, how fast does the network heal when a cable breaks?
So that's a great question. The network will heal in a matter of milliseconds. So today, when we lay in flows between two devices, if that breaks, we calculate the next fastest route and we lay in all those flows. And that typically takes a matter of milliseconds. So recovery generally doesn't require you to lose. There's no comms lost in general. Now, I can't promise that if it's a 1,000 switches from one end to the other, that just overhead in the network itself and having the switches do all that might not take a little longer than we'd like. Maybe it'll take 100 milliseconds, 200 or 300 milliseconds. But we do have a feature we're building where we allow or lay in a secondary flow, and it's an idled flow that uses the same two endpoints, but the least number of common hops between. So that if the primary flow is broken for any reason because a cable breaks or a switch in the way gets powered off, it's going to be microsecond recovery because it will just enable the existing flow, that secondary flow.
That's wonderful. That's great. And will the switches retain their configuration if the controller isn't there or through a power cycle?
Yep. It once they're configured, they're just like any other managed switch that you may be working with, like a Stratix 5700, 5400. Any managed switch that has a configuration of any sort, if you're not in there configuring it and you cycle power to it, it comes back running the configuration it last knew. This is exactly the same way. If you power cycle switches, that config is sticky. It comes back fully functional and fully operational.
Wonderful. All right, last question for you before we sign off here. Is there any type of high availability for the controller and SDN network?
Yeah, you can run our controller in with a secondary. So you can have a primary controller and a secondary, which sync themselves together. And if the primary goes down, the secondary takes over. When the primary comes back, they sync themselves back up. So yes, for those situations where you want to have a secondary controller because you don't want the controller gone and you want all that enunciation and the tracking and logging, yep, you absolutely can run it as a secondary.
Wonderful. Well, thank you again so much for this presentation today, Jeff. And thank you to Kaz for being our resource out in the comments section. And thank you especially to all of our live viewers for your time today. We hope the session was informative and engaging for you. Remember to subscribe to the McNaughton-McKay YouTube channel for more industry content like this. And we look forward to seeing you live again soon. Happy holidays, everyone. Have a great day.